So I want to tell you that I spent about 28 years of my life being in the cardiac cath lab. So I've been an interventional cardiologist 28 years. And currently I head the Department of Cardiology at Clear Lake. And thanks to the effort of several of my colleagues who have nurtured me, mentored me, recently got a research professor appointment at University of Houston, Clear Lake. So, Dr. Huja, who was here last time, is also here. So we're going to challenge some of his concepts. So whenever you listen to somebody, you got to figure out their bias as to what is their bias, why are they presenting information a little differently than what you would expect. So in order to address bias, the best way to start that out is with a metaphor. And suppose, let's say that Dr. Byrne and I, since he's been here, become really good friends, and he's a mentor, and he kind of teaches me, structures my opinion. But unfortunately, he happens to be a fan of the New England Patriots, which is a football team. And since I spent some time and my family has roots in New York, I'm a fan of the New York Giants. And one Sunday afternoon, he and I are watching a football game. I'm a fan of Philadelphia Eagles because coming from the East Coast, and he's a fan of the New England Patriots. And we're watching a football game. And what happens is that I think that I like and respect him, but I really think that despite all of that, he's a little football challenged. So here it is. The Eagles are 25, the Patriots are 30. It's about fourth quarter, about 9 seconds are left on the shot clock, and we are at the 12-yard line. The Eagles have ball possession, and the quarterback falls back into the pocket, is looking for wide receivers. Wide receivers span out, and lo and behold, he finds a wide receiver just as time is running out, and that wide receiver makes a spectacular catch, and the referee says touchdown. All Eagle players run on the field saying that, hey, this is victory. But wait. And the question that comes up is that did he have both his feet inside the line before he received the ball? Did he have possession? So Jumbotron is called in for review, which is the review, and that's the question they're asking. And I turn to Dr. Burns and say, hey, look at that. It was a great catch. He was totally in. I don't even know why they're reviewing it. And Dr. Byrne has a scowl on his face since he's a Patriots fan, and he says, that was completely out. I can't believe you didn't see it. You must be crazy to think that it was in. So what just happened? What just happened is that we came to two diametrically opposite conclusions despite watching the same event. He had same access to information as I did. And so I'm using this as a metaphor, which is very nicely shown by Dan Ariely, that our bias and expectations make us receive and interpret information differently. So what I'm going to try to present to you might be a transformative experience, because you might think about cholesterol, about statins very differently, and you might use your critical thinking skills, or you might go from here and think that, hey, this presentation creates so much anger and resentment in me because the data is being taken out of context and is being presented in a way that is not right. So this is Dan Ariely. He's written a beautiful book called Predictably Irrational. I would all ask you to look that up. So what I propose is that we need to start looking at cholesterol very differently, because when we think about cholesterol, we think about it as bad. But if you look at it, it is an essential component of your cell membrane. This is a phospholipid bilayer cell membrane. There is cholesterol in it that anchors it. It gives it fluidity. It permits wrong substances from getting inside the cell membrane. When you come to the brain, about 25% of the body's cholesterol is in the brain. And cholesterol forms these rafts which hold the receptors for neurotransmitters together. So if you don't have these lipid rafts, neurotransmitters don't function. I won't be able to stand here and give this presentation without cholesterol being taken up by my adrenal glands and converting it into the stress hormone hydrocortisone, because any such activity gives you stress. The body has a stress response. The cholesterol that is used to make hydrocortisone, because hydrocortisone is a cholesterol product, gets into the adrenal gland from the LDL, which is a low density lipoprotein. The reason we have sexual differences, the reasons we have hair and different sexual organs, is because of testosterone and estrogens. These are cholesterol byproducts. Unfortunately, a testis and ovary cannot make cholesterol by themselves. They depend on LDL to supply cholesterol so that the cholesterol from the LDL can be converted to these respective sex hormones. Our bile acids that we make to absorb the fat that I asked Dr. Byrne to eat is a cholesterol byproduct. It emulsifies the fat. So if we didn't have cholesterol, we would not make bile acids. There is a 2.5 billion years of relationship between the human skin and the sun. And this is important because the sun hits the skin and converts the cholesterol in the skin to vitamin D, and vitamin D is an essential, it's not a vitamin, but it's a hormone that provides a lot of protection from injury. The flu season is coming up because we are approaching winter. A deficiency of vitamin D is one of the primary responsibilities, a primary responsible factor for flu. So when I talk about cholesterol, I want you to think about it very differently. And when you talk about it from a cardiology standpoint, you talk about LDL cholesterol. So what is LDL cholesterol? So if I take a beaker of water and put oil in it, the oil and water don't mix. Similarly, both cholesterol and triglycerides are fat, and our blood is aqueous, it's watery. So the cholesterol and fat don't mix. So the body needs to transport cholesterol in the bloodstream. How does it do that? It does it by making a lipoprotein molecule. So here is a VLDL, it's a low density lipoprotein that is secreted by the liver into the circulation. It's got a phospholipid outer layer. It's got certain key identifying proteins that give it a function, and the cholesterol is the cargo of that. So the cholesterol is inside. So when you talk about LDL cholesterol, that cholesterol is not any different than the cholesterol found in HDL or in VLDL. It's just a different lipoprotein. Okay, so I have enumerated many different functions because I want you to stop and think, why does the body make an LDL cholesterol? Does it have any reason? Is the only role of LDL atherosclerosis? Of course not. There are several roles that I have pointed out here. I want you to glance at it, don't memorize it, because I'm going to go into detail in many of those. Okay, so we said that the liver excretes or secretes a VLDL particle into the circulation. It's got a phospholipid outer layer. It's filled with triglycerides, which are in green, and the cholesterol, which is in yellow. And what is the primary reason why the liver makes a VLDL particle? Because I want you to think about it. The primary reason it makes it is because it's an energy delivery vehicle. Because triglycerides, unlike what we have forgotten, we need to remember that triglycerides are used by the heart, by the muscles, and what we cannot use is then stored in our adipose tissue. So the primary reason why the VLDL is made is because it's an energy delivery source. Now what happens when it dumps all the triglycerides into the muscle cells or into the fat? Then it becomes triglyceride poor, cholesterol rich, and then it is called an LDL particle. An LDL particle has many support functions. So the primary job of VLDL, which is the father of the LDL, is to distribute energy to the cells. So if you just took this from this lecture, you would get enough information. So we have two competing sources of energy in our body. One of them is carbohydrates, the other one is fat. So how much carbohydrate do we carry? If you take me and you dump the entire blood I have, which is 5 liters, and you measure the amount of sugar that I'm carrying in my blood, would it surprise you to know that it is only 5 grams, a teaspoon? It shouldn't. So sugar in our blood is tightly regulated. How much carbohydrate can we store as glycogen in the liver to supply when the sugar runs low? About 100 grams, 1/4 of a pound. How much glycogen can we store in our muscles to supply exercising muscles? About 3/4 of a pound, 300 grams. But the glycogen that is present in the muscle cannot be used by the brain. We lack an enzyme to release it into the circulation. It's only reserved for the muscle. So basically, your storage form of carbohydrate is only 100 grams. So what I want to propose to you is that we evolved as fat burning animals. We didn't evolve as carbohydrate burning animals. That is a phenomena of the industrial age of agriculture. So the total carbs that we can store is only about 100 grams because muscle glycogen is reserved for the muscles. On the other hand, at this time and age, we store about 60 pounds of fat as energy source. This is 1965, and if I'm not mistaken, this is Clark Gable. He was 165 pounds, average American. Turn 50 years later, an average American is roughly 50, is several pounds heavier. And so we carry more fat. And this is a result of nutritional guidelines. So there was an experiment that was done, which is a part of the next slide. They took 8 volunteers and said, we want you to not eat anything for 7 days, just fast. So you will be given water and salt, but you will not be eating anything. So here is the slide that shows that at the beginning of their fast, their LDL cholesterol was about 112. They're fasting for 7 days. What do you think happens to their LDL cholesterol? Go up, go down? So you see in the slide that it went up by almost 70%. So I want to tell you, why do you think that the cholesterol went up by 70%? Why did the LDL cholesterol go up by 70%? The reason is that you run out of carbohydrate sources within the first 1 day. How are you going to transport energy in your bloodstream to supply your cells? You're going to transport it as fat energy. And that fat energy is going to be used up and LDL is going to remain. So if you take somebody, and if you think fasting is beneficial, then you better put them on a statin if you think LDL is bad, because their cholesterol is going to increase by 70%, as it's shown out here. All right.
We see that in patients who have nephrotic syndrome, that the cholesterol rises very fast. You see very, very high cholesterol, and the reason is because the low albumin stimulates the liver to produce a lot of lipoproteins, which carry it. I think it could be the similar reason here that your albumin is dropping with your nutrition, and it probably produces more lipoproteins. That's why you see increased LDL.
That's a good point. The whole liver metabolism is probably jacked up, and that's why the VLDL and LDL goes up. If they're using the VLDL will become an LDL particle, otherwise the triglycerides go up. I want you to think back and think about CoQ10. CoQ10 is a cholesterol byproduct. It comes from the same path through which you make cholesterol. So if I take you back, so I'm comparing CoQ10 to a spark plug. Without a spark plug, you cannot burn fuel. Similarly, without CoQ10, the mitochondria cannot burn fuel. So if I take you back to medical school, in which you think about the citric acid cycle, the Krebs citric acid cycle, and then you couple that to the electron transport chain, the electron transport chain has CoQ10 as a catalyst, as cofactors. Without CoQ10 being present, you don't have the proton fluxes that are needed to make ATP. So our energy currency is highly dependent on having an adequate level of CoQ10. Okay, so does giving statins affect our muscle function? So these were researchers that took a rat model, four groups, a placebo group, a CoQ10 group, a statin group, and a statin plus CoQ10 group. And they said we're going to check muscle function by checking what the muscle weight was in the rat, by putting them through an exercise performance test. It's a rat exerciser called Rotarod, and by checking enzymes that reflect muscle breakdown. So this is time scale here, 21 days. This is the amount of muscle loss. You can see that the atorvastatin group did not grow, their muscles atrophied, whereas the control group had an increase in their muscles, whereas when you added CoQ10, it was somewhere in between. What about muscle injury that you can measure by increase in cardiac enzymes, the CK or the muscle enzyme CK or myoglobin? In the atorvastatin group, the muscle enzymes were much higher in the blood at day 14 and day 21, and the myoglobin was 5-fold higher compared to control. It was attenuated to some degree by giving concomitant CoQ10. What about exercise performance? So this is exercise performance. Exercise performance went down in the statin group both at 14 days and 21 days. In the atorvastatin group, significantly compared to the groups that were given placebo. So you would say rats are not similar to humans. Is there any human data on this? So this is Dr. Thompson, and Dr. Thompson is similarly conflicted like I am, because he receives research grants from almost every statin manufacturer out here. So you would expect that his bias would be different than mine. He would try to find that the statins don't cause a problem. Yet when he did this experiment for 6 months, and these are not elderly people, these are healthy people at age 420 healthy people who didn't have any problem. And as you see, as they were getting older recruits, the activity, the physical activity of these people was going down. Most of the people who take statins are in their 50s, and it's going to impact their physical activity a lot more than the younger people. Is there evidence that giving statins will cause muscle injury? So it's the same group of people, and now I'm telling you these were given only for 6 months. Statins are given for about 30 to 40 years. So in a 6-month time period, in this 420 people, there was a statistically significant increase in CK and a statistically significant increase in liver enzymes in the 420 humans that we investigated. So what is there is that there is evidence of both biochemical, muscle, and biochemical liver damage. At the beginning of the talk, I said that memory and cognition is vitally served by cholesterol, because cholesterol holds these neurotransmitter receptors together. So I want to take you and tell you whether taking cholesterol reducing medicines reduces your cognitive ability. So this is the Lothian birth cohort. It was done in Edinburgh. It's apparently called Edinburgh if somebody is British out here. I call it the British, the American way, the Edinburgh. So there were a group of people there, about 1,000, and they had their mental survey done when they were age 11, and then they were traced back somewhere in the early 2000s, and these participants took a cognitive score again, and their cognitive score was compared with serum cholesterol levels. So at age 70, you're comparing their cognitive skills in relationship to cholesterol and statins. So what they find is that this is the low cholesterol group, which is in blue, less than 200, intermediate cholesterol, which is 200 to 240, and high cholesterol, which is greater than 241. And like you see, women are smarter than men, and there were more women that had high cholesterol than men. There were 30% men, 70% were women. More professionals had high cholesterol. More managerial people had high cholesterol. The non-manual people had higher cholesterol. The manual people had lower levels of high cholesterol. And the physically inactive people had lower levels of high cholesterol. What about high blood pressure? High blood pressure, the higher your blood pressure was, the lower your cholesterol was. The lower your blood pressure, or the lower the risks of hypertension, the higher cholesterol group that you belonged in. Strokes were very similar. The strokes were highest in the low cholesterol group. I want to go on a tangent here and talk about World War II Japan. World War II Japan had cholesterol levels that were about 50% lower than the Americans. The incidence of strokes in World War II Japan was 15-fold higher than that was there in the US. As Japan became affluent and they started eating animal food, their cholesterol levels went up. What happened to their stroke rate? It disappeared, it went down. So higher your cholesterol, lower the risks of stroke. I wish that there was a neurologist here. What is the first thing you give to a patient who has a stroke? You give them a statin. Coronary artery disease was the lowest in the highest cholesterol group and the highest in the lowest cholesterol group. I told you about cognitive ability, which is measured at general functioning, processing speed, memory. Uniformly, the lower your cholesterol was, the worse your cognitive and memory skills were. Higher your cholesterol in the Lothian birth cohort, better were your cognitive and memory skills. What about verbal ability? Verbal ability was the highest in the highest cholesterol group, lowest in the lowest cholesterol group. IQ similarly, high in the high cholesterol group, lowest in the low cholesterol group. Now we are looking at cognitive function and looking at the effect of statins. There were 1,000 patients in Lothian birth cohort, 300 were on statins, 700 were not on statins. When you were on statins, your ability to process information, processing speed, memory was uniformly lower compared to the non-statin users. Similarly, statin users had lower verbal ability and lower IQ compared to the non-statin users. Now you may say out here is that correlation is not causation. I completely agree. There are several factors that determine your IQ at age 70, not just LDL cholesterol or total cholesterol, is education, exercise, social status, smoking, but it's nevertheless compelling for us to look at this information and say, are we doing something wrong in our critical thinking when we treat patients? And Dr. Prince walked in at the right time because these slides were completely geared towards him. Would you ever think about an LDL cholesterol as host defense mechanism? So let me rephrase that question. Would you ever think of an LDL cholesterol as contributing to host defense? So here is an experiment that is done in rats. These are Staphylococcus aureus, and Staphylococcus aureus have this thing called quorum sensing. So quorum sensing is a very catchy word, and like to use it. What quorum sensing means is that the Staphylococcus aureus releases a protein which goes into the circulation and sees, hey, is this environment good for me to start multiplying and create bacterial virulence? So here is this protein which we will call AGR, and you will see that it releases the AGR into the circulation. Here is AGR being released into the circulation. It comes back and says, quorum is established. Let's have bacterial virulence, and bacteria multiply and take over the host. So if I were to tell you that this accessory gene regulator protein is neutralized and inhibited by the LDL particle. So here it is. The LDL particle comes in and soaks up this AGR protein and prevents the quorum from being established, so bacterial virulence and multiplication is prevented. This is very nicely documented in some beautiful basic science studies. Now, what about inflammation? Bacteria release LPS and LTA. These are inflammatory mediators. They create inflammation that leads to cell death. What neutralizes these inflammatory mediators? And that again is the LDL particle. The lowly LDL particle comes in, takes in the LPS and LTA. It's neutralizing bacterial inflammation. And then it is reducing bacterial virulence, so the bacteria cannot gain a foothold. Several patients who are dying in the ICU are given statins without being discontinued. All right. There is a way in which we recycle the LDL. The LDL goes to the liver where there is an LDL receptor, and the LDL receptor picks up the LDL, puts it back into the liver, and then since the liver does not want to give up anything that is important, the LDL receptor is endocytosed, the cholesterol and the lipoprotein and fat are recycled. But there's a condition called familial hypercholesterolemia in which the LDL receptor doesn't work or is absent or is deficient. So this person has about 5 to 7-fold the number of LDL particles compared to a normal person. So this would be an ideal person to see if they are at risk of infection, or is LDL reducing the risks of infection in these mice. So here is an LDL receptor deficient mice. It has much higher LDL, about 9-fold, about 5-fold higher than the wild type mice, 400 versus 90 milligrams. And these mice were challenged with the lipopolysaccharide, which is an inflammatory product, or were challenged with bacteria itself. So two groups, okay. So here is the amount of LPS, here is mortality. At lower amount of lipopolysaccharide, the wild type mice dies, whereas the receptor deficient mice that has high levels of cholesterol is able to resist the inflammation. The reason for that is high levels of LDL. So here it is showing that inflammatory mediator production in the normal mice that has low LDL is high, whereas in the mice that has high LDL, which is receptor deficient, is lower. So the same mice infected, given lipopolysaccharide, high LDL is protective. This is their LDL concentration, 9.55 to begin with. After LPS, the LDL cholesterol is used, it goes down. After giving bacteria, which is Klebsiella pneumonia, it also goes down, but it doesn't have the similar drop in the mice that are wild type because their LDL cholesterol is not high to begin with. Now this is the same experiment in which the wild type mice was given Klebsiella pneumonia inoculation. All of them died before 2 days. Whereas 30% of the mice that had high amounts of LDL were able to survive. Okay? Compelling information from my studies. You will say it doesn't translate to humans. So this is a town of Leiden in Netherlands. They took 724 patients who were over 85 years of age and said, we're going to follow these patients for 10 years and we're going to study their cholesterol levels and see which group dies earlier. Okay? 85 years and older, 724 patients. So they divided them into 3 groups. A group that was very high cholesterol, greater than 250, a group with intermediate cholesterol, 200 to 250, and a group with low cholesterol, less than 200. you would predict that these guys have been suffering from hyperlipidemia for 85 years. They should drop dead any moment from high cholesterol. Okay, all-cause mortality. Was it the highest in the highest cholesterol group? No. It was highest in the lowest cholesterol group and the lowest in the highest cholesterol group. Now you would come back and say people who have low cholesterol are so sick, they are debilitated, they have malnourished, and so their cholesterol is low, so they're going to die. But the researchers said, okay, we're not going to count anybody who dies for the first year. We're going to eliminate all of those and then see if it is statistically significant. The same significance held true. There was no difference in cardiovascular mortality statistically between the three groups. Cancer mortality was much lower in the group that had high cholesterol compared to the group that had low cholesterol. Something that Joe deals with all the time is that elderly people die of pneumonias. So you would expect that mnemonic death from pneumonias should be lower in the highest cholesterol group, and it was. The higher your cholesterol, the lower the risk of death from respiratory infections. So cholesterol is an important part of the cell membrane, and here is a depiction of it, and I don't know if it will play or no. It's not been playing for being. I have a very nice GIF slide. It doesn't want to play, but anyway, when membrane is damaged, the LDL supplies the cholesterol for membrane repair. Okay, so let me say that again. When cell membranes are damaged, they have cholesterol inside it, and what provides the raw material for membrane repair? It's the LDL cholesterol. So it's shown out here. LDL is endocytosed. It is taken inside the cell. The cholesterol is released as free cholesterol, and through a series of beautiful biochemical steps, it goes back up to the cell membrane to create a repair mechanism. So in other words, the cell starts migrating and help repair damaged endothelium. So this is what I'm showing you out here. This is the LDL sufficient serum, this is the LDL deficient serum. In cell culture, the cells that had LDL sufficient serum were making the transformation to repair the cell because there is migration, whereas there is no migration out here. Taking it to a clinical situation, here is a vessel wall, there is disruption of endothelium. This can lead to a blood clot that can cause a myocardial infarction. The LDL is there for cell repair. It is there to repair the cells so that you get into a situation like this in which the endothelium is repaired and there is no blood clot, rather than coming into a situation like this in which there is no repair followed by a blood clot. Now, I don't know if Dr. Lewis does breast cancer surgery or no, but if she does, so what I want to tell is that the risks of breast cancer increases dramatically with statin use. This is ductal breast cancer, this is lobar breast cancer, this is non-statin users, less than 5 years of statins, 5 to 10, and greater than 10 years of statins. With greater than 10 years of statins, your risk increases twofold. Your relative risk is greater than twofold. Okay? Now, we started a little late. I'd like to take about another 5 minutes to finish, or you guys want to stop here?
Keep going.
So, steroid hormone synthesis depends on cholesterol being supplied to the liver and to the testes. And we can see that when we give statins, the testosterone levels, the free testosterone, total testosterone level falls in men. Not only does the testosterone level fall, but the French have shown this very nicely, that statins are associated with erectile dysfunction. There's a very high incidence of erectile dysfunction in statin users compared to non-statin users. What about mortality? This is a study done, a Norwegian hunt study. People were followed for 10 years. This is 50,000 patients. And after being followed for 10 years, this is looking at total mortality, this is looking at cardiovascular mortality. The higher your cholesterol, the lower your mortality in women, and also to some degree in men. Cardiovascular mortality still continues to be lower in women, seems to be sort of not different in men. No relationship in several population-based studies in terms of LDL or total cholesterol in terms of increasing mortality. In fact, the higher your LDL cholesterol, lower your mortality. I put the slides together by doing a lot of research into the FDA database. So we say that a randomized clinical trial is the strongest level of evidence. But randomized clinical trials are done by the pharmaceutical industry. There is a run-in phase. So in other words, if the drug is not suitable, these patients are thrown out before you randomize. You ask the wrong question, you're looking for a tiny effect, you have a biased design. But that's not the only thing. After you divide them into the intervention and placebo group, who is gathering the data? It's either the industry or a stooge of the industry like Duke Clinical Research Institute, which probably is one of the best. It is not gathered at 1 or 2 centers. It's 400 centers in 25 different countries, and God only knows, many of us come from countries in which there is a lot of corruption, in which data is not properly gathered. This data is collected by the drug industry, then it gets presented to a central adjudicating committee, which again is employed by the sponsor. These are expert doctors that are handsomely paid. And then this is presented to the FDA. How many of you know that 3/4 of the FDA's budget, let me say that again. How many of you know that 3/4 of the FDA's budget to approve new drugs comes from the drug industry and not from the government? Did any of you know that? 3/4 of the budget. So in other words, the FDA people are working for the industry. So this is one clinical trial in which I participated in. This was a trial in which we were using Efficient after giving stents, done at Baylor College of Medicine. So when I enroll a patient and if they had a heart attack, I would do what is called a site-reported myocardial infarction. All of this information is then collected from 400 different sites. It's given to the industry. Then the industry brings about a team of experts that they call Central Adjudicating Committee to see if Dr. Ali made the right decision when he reported that there was a true site-reported myocardial infarction, that this actually happened. And they review that and say, well, we don't know if that happened. We are going to come up with what is called CAMI, Centrally Adjudicated Myocardial Infarction, or CAMI. CAMI decided by the CAC committee. Okay? So this is the same Efficient trial, Efficient arm, 13,000 patients. The site-reported myocardial infarction by investigators like me was 226 in the Efficient arm, 298 out here. But when it went to the CAC, the CAMI found suddenly that I was missing all these myocardial infarctions. Let's double it up to 475 and 620, but let's find a lot more in the standard group than in the Efficient group. Here the P was not significant, here the P becomes significant. These games are played all the time by drug industry, aided by people like us, by physicians like us. This is the Berlinta study. It's called the Plato trial. Again, blood thinners to prevent myocardial infarctions. Berlinta arm, standard arm. This is the site-reported MIs. This is the site-reported MI in the standard drug, which was Plavix. 504, 548. When it went to CAC, suddenly the CAMI found that investigators like me missed 45 myocardial infarctions only in the standard group and none in this group. How does that happen? A P that was not significant becomes significant, and then people like me can come in front of you and say, hey, use Berlinta, don't use Plavix. And we get paid handsomely for going in the evening and maybe $2,500 or $3,000 to just go in front of a group of people and say, use that drug. I took this slide from the paper, and it's inspired by one of my friends, which is called David Diamond. If you read the paper, it says Lipitor reduces your risks of heart attack by 36%. That's so amazing. I would want to get Lipitor. I would want to go there and get it right now. So this is the study on which it was based. It's called the Ascot LLA trial. I think there were about 10,000 patients followed for 3 years. And I'm going to try to find out where the 36 benefit in heart attacks and cardiac death is. So what I have done out here is to show you the number of people enrolled who did not have a myocardial infarction or CV death. When you look at CV death, there was really no difference. So we are really looking at this. It's a combined endpoint. And the difference was less than 1%. At the end of 3 years, there is less than a 1% difference. So how is the drug industry going out and putting out a paper that says there's a 36% improvement? Where is the 36% improvement? So here is 1% difference between the placebo group and between the placebo group and the treatment group. So difference is 1%, and what they do is they divide the 1% by about 3%, which is the difference between the main group, which between 100% and 3%, and come up with the number of 36%. So it's written out here. Jesus, sorry about that. This is the font in which it is written. The mean was only about 1%. It's written on a blue background with blue font so that you don't get to see it. Nobody reads it. So really, if I were to have truth in advertising, I would say Lipitor reduces the risks of heart attack by 1%. And if it did that, Lipitor would not be the highest grossing drug ever produced by the drug industry. It is still one of the highest grossing drugs. And we physicians fall for it. Several of you may have patients who are getting Pcsk9 inhibitors. These inhibitors are ones that go to the liver and tell the liver to soak up all the LDL from the circulation, makes the receptor work better, so their LDL falls to about 30 grams per deciliter. So this is a study which is called the Fourier Trial. 28,000 patients were enrolled. The difference in LDL 90 for people who were placebo given statins versus 30 milligrams with people given the Pcsk9 inhibitor. 28,000 patients followed. If you follow 28,000 patients and more people die in the treatment arm, which is the arm that got the Pcsk9 inhibitor versus the control arm, you should say, I want to pack my bags and go home, that this drug does not work well. But this is touted at American Heart Association, saying that this is a quantum leap forward in treatment modalities in cardiovascular medicine. I want to tell them that dying with corrected cholesterol is not a successful outcome. So in my practice for the last 5 years, I've been telling people to eat like this: cook in lard or butter, eat a lot of milk products that have cream, triple cream cheese or sour cream, eat fatty fish, tuna and salmon, eat the skin of the chicken. When you go to the supermarket, buy the fattiest meat possible, eat bacon and lamb, marbled meat. So when you start eating like this, and I have experience for 5 years, your HDL uniformly goes up. Your triglycerides, which is fat in blood, goes down. And as you get healthier, and not many people will tell you this, as you get healthier, your LDL will go up. And when your LDL goes up, I want you to celebrate, because you're going to live longer, you're going to be smarter, you're going to have better mathematical skills. The LDL uniformly improves to the large and fluffy, the good kind of LDL. On the other hand, standard American diet is like this: sugar, grains, and vegetable oils. This is the perfect trifecta for bad health. It could be coined as a donut. Sugary fruit that we tend to consume is not far behind. So 60% of American calories are coming from grains, added sugar, and plant oils. I fear for the vegetarians, because the vegetarians, they don't have any animal food, and they take a lot of plant oils, very high in omega-6, badly chemically produced, highly inflammatory. When you do this, your good cholesterol goes down, your triglyceride goes up, your LDL may not change, but you get this phenomena called severe insulin resistance. Your insulin levels go up dramatically. And if I were to tell you about my patients, about 70% of my patients have insulin resistance. 70% of the US population has insulin resistance. Insulin resistance leads to diabetes, heart attacks, dementia, obesity, toxic hunger, because when you have high insulin levels, your body does not see leptin. It makes you think that you're hungry all the time. There is a higher risks of cancers as well as polycystic ovarian syndrome, which many young women suffer from. So I should have put out here mainland medical staff, but really what we are getting is a Trophula seed. And unless you guys think differently, and unless there is a grassroots effort for you to say, I'm going to use my critical thinking skills, I'm not going to be sold by the drug industry in terms of prescribing drugs, I'm going to be listening to my patients, unless you care a lot, we're going to still be a stooge to the pharmaceutical industry, and we're going to treat cholesterol with statins when we shouldn't be doing that in majority of people. So I said lipoprotein, cholesterol, we need to educate our students because very little is taught about lipoprotein. All that is taught about is how LDL is bad. We don't recognize that LDL is an important energy delivery source. That I wanted Dr. Prince to be here to recognize that LDL is a very important innate host defense mechanism that is involved in cell repair and reducing the risks of malignancy and helping appropriately with apoptosis. That it is important for our muscle function because CoQ10 comes from cholesterol. That our cognition and memory depends on cholesterol, that our sex life depends on cholesterol, that our overall mortality depends on cholesterol. And somehow we need to figure out that the drug industry is not our friend, they're out there to make a profit. I want you to go there and buy this book by this Danish guy, Peter Gotze, Deadly Medicine and Organized Crime. He details the pharmaceutical industry very nicely. And last slide. So, you know, I have been a target of criticism at Clear Lake Hospital. Many people have gone to administration and complained about me saying that this Dr. Ali is doing wrong by his patients. He is taking people off of statins, and I don't do that. I give patients the data, they decide. It is an informed consent. It is patient values and preferences that I use in doing that. But I have been a target of ridicule. People have actually come to me with legal liability issues. I stand here at risk of being disciplined by medical boards. I can have my license suspended, so I have started a GoFundMe page to help my defense. So that's all I had. No, I just want one more minute. I'm running a low-carb conference at University of Houston on October 25th to 27th. So 1 month from now, exactly 1 month from now. I want all Clear Lake and mainland medical faculty to come. The conference has a registration fee, but I have said I'm going to waive the registration fee if you promise to attend. If you give me your name, you text me your name and say you're going to come, I will have a registration batch ready for you. There are 20 of the world's experts coming from Australia, Sweden, Ireland, Canada, several from the US to give us information about cholesterol, about fasting, about insulin resistance, and how to improve the health of the local community. So that's all I had.